Oh, we're gonna find out all about it?
I don't want to. Hey, we're so
What?
tired.
And we have to spend all.
Oh, James, great.
I'm gonna do like, depending on how willing you guys are to let me, I have like 30 minutes of
When are we
talking.
gonna have our function with everyone?
Okay.
That's what I'm saying, dude.
But it's
I'm
it's
waiting.
gonna
I'm
go
waiting too.
It might happen.
When?
quite
We're
bad.
all We'll cry up, we'll cry up. I'm gonna text it myself and take back my Sorry.
So what we're gonna be talking about here in section 4.1 are the inverse trig functions. So sine inverse, cosine inverse, tangent inverse, secant inverse, cosecant inverse, cotangent inverse. Everybody's okay with that? And we're going to talk about how to use those in order to solve trigonometric equations. So that's like the end goal, is to be able to do some solving problems that involve sine, cosines, tangents, etc. Everybody cool so far with the plan? So what I want to start with is kind of reviewing with you guys what these inverse trig functions do, right? Everybody's all right? Because I think a good conceptual understanding goes a long way to like making the procedure we're about to do easier. Okay? So you remember this first graph that we're looking at is the graph of sine. So remember the x-axis is y, or is theta, excuse me. And the y-axis, since it's sine, corresponds to a y-coordinate from the unit circle. Guys okay? You remember that? So from your Algebra 2 class, if I want the inverse of this function, it's going to be the graph gets reflected across the line y equals x. So this graph here is the graph of sine inverse of x. When you look at that graph of sine inverse, what is the problem with it? Because there's a problem. Should jump right out at you. No, I mean, that's not really an exponent. That's just like a notational thing. It doesn't mean like 1 over sine. It means inverse in that notation. Just in like the same way we have like y equals f of x and then y equals f inverse of x. That doesn't mean 1 over f of x. It's just like part of the name, right? But there's a problem with that graph. Anybody see what the problem is? Undefined, what do you mean? Because it's up, the up and downness is the problem. Why is that a problem? It's not because it's undefined.
Because there's multiple y-intercepts.
There's multiple y-intercepts, great, which means that
It's not on the x-axis.
well, it's not the. What's that, James? Never mind. So, if I ask, let me ask you a different question. Get us a little bit more focused on where I'm trying to get to. But these things are fine. These are good ideas. If you look at that graph of sine inverse, is it a function? No, why not? What was the way, there was a check that we used in Algebra 2 to check if a graph represented a function, right? The vertical line test, yeah. Does that pass a vertical line test? Heck no, it doesn't. So, it's not a function, right? That's sad, right? If it's not a function, what that means then is that we can't like program something into a calculator to do that, to simulate that function for us, because if I have one output, or one input, it's going to have like infinitely many outputs. Right? If I put in x equals 0, I get infinitely many y-intercepts, right? That's bad for us. So the solution, what we do, is instead of taking the entire graph of sine, we restrict its domain. So we only say, okay, what if I just worry about that part of sine? If I do that, then like that's all of the inverse, sine inverse. Does that now pass a vertical line test? That pass a vertical line test now, the blue graph? Yeah. Does it cover all the possible y coordinates that sine can have? Yes, right? Because all the possible y coordinates are like stuck in between the orange, right? So this will do what we want it to do. So this is really what we call the graph of sine inverse. Is that restricted piece, because now I can program this as a function into my calculator because it's a well-defined function. It doesn't have more than one output for me. As a piece of notation, sine inverse of x and the function arc sine of x, they mean the same thing. So one is an older notation. I use both interchangeably in homeworks and stuff. They mean the same thing. Depending on the age of your textbook or the preference of your instructor, they may use one or the other. They mean the same thing. I'll use them interchangeably. Everybody's okay? So if I look at this, when I restricted the domain for sine, I did that because it still covered the entire range for the sine function. Let's write it simply. So when I go down and I look at the domain for this, the domain for sine inverse is going to be, remember how to do, if I take a function and I make its inverse, what happens to its domains and ranges? They flip. Yeah. So the range for sine was -1 to 1. So the domain for sine inverse is going to be -1 to 1. The domain for sine was -π/2 to +π/2. So the range for sine inverse is going to be -π/2 to +π/2. Is everybody okay there? So we can do the same things for cosine and tangent inverses. I'm not going to go through the whole graph rigmarole again because it's like the same process over. Is that okay? I'm just going to write down their domains and ranges, and we'll talk about how to use those in a moment. That might be something good to put on a note card if you're starting to make your note card for the next test.
Does that never change?
Never changes. So, if I take out my graphing calculator and I do the sine inverse, and I try to do the sine inverse of 3, what's going to happen? What? Somebody mumbled something. Error is correct. Why, Kara? You don't know? Yeah, 3 is not between -1 and +1. It's not in the domain of sine inverse. When I type that in my calculator, it's going to say error domain, saying you're asking me to do something I cannot do. Is everybody okay with that? Okay. Will the same thing happen for cosine? Sure. Will the same thing happen for tangent inverse? No, because the domain for tangent inverse is all real numbers. Why is tangent inverse different than sine and cosine? Yeah, so what Gabby's saying here was the graph for tangent looked like this, right? So when we reflect it, tangent inverse is going to look like that, right? Where the covers the whole x-axis, but only through 2 specific y's. And notice that these are strict inequalities here, because those correspond to the vertical asymptotes in the graph of tangent, right? So today, what we're going to focus on is doing excuse me, doing the inverse functions without a calculator, and then solving trigonometric equations that can be done without a calculator. Okay? And that's the 2 things that we're going to look at today. I have a handout for you guys to work on when I finish. Everybody's good? All right. So if I ask to find the exact value of sine inverse of -1/2 without using a calculator, the tool I'm going to need is my unit circle. In this class, if anything is asked for exact value involving sine, cosine, tangents, means we need our unit circle. If you have your unit circle still with you, which you all should, I invite you to take it out so you can kind of follow along. I'll have one projected on the screen, but I imagine by the time you're in the back of the classroom, that's awful hard to read. So it helps enormously if you have your own to look at. If you have lost yours and you're like, oh, I need that still, what could you do? Yes, if you go back to the chapter 2 section in OneNote, there's the unit circle file you could print off, open the PDF and print your own. Okay. So, let's talk through how to do this, because it's a bit of a visual exercise. So you really need to kind of watch what's going to be happening and look at what's going on, because this is something you really see with your eyes. It's not like nothing you're going to be like computing out right like this stuff. Okay, very visual. The first thing we want to do is observe what type of inverse we're doing. Is it a sine inverse, cosine inverse, tangent, whatever? So it's sine. Because it's sine inverse, the range for sine inverse is from negative pi over 2 to positive pi, right? What two quadrants on the unit circle are covered by the angles negative pi over 2 to positive pi over 2? Well, if I start at 0, now I want to go to negative pi over 2. Which direction am I rotating? So clockwise. And how far is pi over 2? $90 degrees, right? So I'm covering quadrant 4. And then how far is it from 0 to positive pi over 2? Which way am I rotating? Counterclockwise. And pi over 2 is 90 degrees. So I'm covering quadrants 1 and 4. Is everybody okay with what I've done there?
I didn't know that.
Because I remember that the conversion factor between radians and degrees is pi over 1, which means that pi radians is 180 degrees. So pi over 2 is 90 degrees. Is that okay? Again, that's a fact. Plus, when I look at my unit circle, pi over 2 and 90 degrees are in the same spot, right? So if you forgot that, it's on the unit circle. Everybody still with me? Yes?
How do you make it negative? You just go the other way.
Correct. So positive angles go counterclockwise, negative angles go clockwise.
Okay.
Yes. Still doing okay. Now, because I'm dealing with a sine inverse on the unit circle, what is sine? Is it the x-coordinate, the y-coordinate, y over x over y, 1 over y, 1 over x? It's y. Remember that from before? So what I'm going to do is I'm going to look for where the y-coordinate is equal to negative 1/2. And where am I going to look for that? In the yellow region that I've highlighted. Notice that's the only spot in the quadrant 1 or quadrant 4 where the y-coordinate is negative 1. See it? You go and you check all the spots in quadrants 1 and 4. That's the only spot.
Is it always going to be the y-coordinate, not x?
Well, it will be if you're doing sine inverse, because sine is the y-coordinate on the unit circle, right?
Oh, and then it is close.
Yep. Yep. So what do I do with that then? Well, that corresponds to the angle 11 pi over 6. Kendall?
Could you like reverse engineer it? Start with the -1/2, see what either x or y that it needs to be in,
And
and
then
then
eliminate.
because it would
based
only
on
be
where it's
like
at.
2
Yes.
on the unit circle, so then you would like
Sure. Yeah, you could start with where is the y coordinate -1/2? Which one of those is in the right place? Sure. You could do it that way also. So that -1/2 corresponded to the angle 11 pi over 6. But we have a little problem. Take a moment and look at it. It's subtle. I'm not sure anybody's going to see the little problem that we have, but there's a little problem. Julius. Nope. Nope. No, the angle has, or the coordinate has to be, why would you say pi over 6? Pi over 6 is in quadrant 1. Our answer has to be in quadrant 4, right? But you're getting closer. What is the range of sine inverse? It's negative pi over 2 to positive pi.
Oh, plus or minus.
Is our angle inside of negative pi over 2 to positive pi over 2? The answer we've quoted, 11 pi over 6. Is that in there? No, 11 over 6 is almost 2, right? That's way bigger than 1/2. Oh no, did we make a mistake? No, we just need to do something else. We have one additional step. So if our angle, our answer that we find on the unit circle, doesn't fall in the proper range, then an angle coterminal to it should. How do I find an angle coterminal? So we add or subtract 360, but we're in radians, so it should be 2 pi is 360 degrees in radians. Is my answer 11 pi over 6, is that too big or too small? Too big. So should I be adding 2 pi or subtracting 2 pi? Subtract. So my problem is that this is not in there. So I'm going to take that 11 pi over 6 and I subtract 2 pi. How do I do that subtraction? 11 pi over 6 minus 2 pi. Great. What would the common denominator be? That's correct. And 11 pi over 6 minus 12 pi over 6 is close. Negative pi over 6. That's our answer. Ooh. Let's do that again, right? It'll get easier once you're practiced up on it, but the first time through, it's a little tricky. Gianna?
You have to show all that work. Isn't it always just going to be pi
Not necessarily. But you don't need to show me doing the subtraction, right? Like, I don't care about that. That is okay. You could. I wanted to do it because when I was grading your most recent test, there are a lot of people that struggled with adding and subtracting fractions in terms of pi, so I wanted to practice that as just another little like, good excuse to practice that skill. Okay, so let's do another example. So here we're doing cosine inverse of negative 3 pi, or I'm sorry, negative square root 3 over 2. First thing I look at is what type of inverse am I doing? In this case, it is cosine. So the range for cosine inverse is 0 to pi. And cosine is, on the unit circle, the x-coordinate. So 0 to pi is going to be rotating. I start at 0. And which direction am I going to be rotating? Clockwise or counterclockwise? Counterclockwise, because the value is positive, right? 0 to pi is only positive things. Everybody agree? So there's pi over 2, all the way to pi. Everybody okay? Where am I going to be looking then?
Why did you go with
I went from 0, 0, and ended at pi.
oh,
The other one, I had to start from 0, and I had to go down to negative pi over 2. And then start at 0, up to positive pi over 2, because the interval didn't start at 0. But here it started at 0. It's actually easier for me to do that. Okay, so inside of quadrants 1 and 2, what am I looking for? I'm looking for where the x-coordinate is negative root 3 over 2. Take a look. Do you see it? Okay. Is final question here, final check. Is 5 pi over 6 between 0 and pi? Yes, right? Well, the fraction 5 over 6, is that between 0 and 1? Yes, because 5 is less than 6, right? So is that between 0 pi and 1 pi? Yes, because 5 over 6 is between 0 and 1.
so if the top one is less than the bottom one, it's less
Correct. Yeah, like 1/2 is 0.5, 3/4 is 0.75, but 5/4 is 1.25, right? Got it? So this guy is our final answer. We don't have to do anything to modify. Oh, that's nice. Should we do more? Let's keep going, right? first thing I do is look at which type of inverse I'm dealing with. Tangent. The range for tangent is okay. And on the unit circle, what is tangent? Okay. Ready to feel so far so good? Let's figure out where we're looking for. Haven't we done this already? Right, that was kind of the same for sine, right? What was it? What quadrants were we dealing with then? 1 and 4. Okay. So what we're looking for is where y over x is equal to -1. Well, no, because it's not inside of where we're looking for. It is. Let's back up and just pause a minute. Let everybody catch up. Oh, that's great. Oh, yes, you guys are right on.
Why is it -1?
It's a good tan inverse. Are you okay so far? So if I multiply both sides by x, really what we're looking for is when x and y are equal but opposite. Right? Where they're the same number but with opposite signs. Very cool. So if I go and I look through, oh, pi over 4, they're the same number, oh, but they're both the same sign. Ah! Same number, but opposite signs.
Does it matter if the negative is the first one?
Nope. Not for tangent. But it does have to be chosen inside of the place we're searching, right? So Gianna had suggested 3 pi over 4, which has equal numbers but opposite signs, but it's not inside of our search space. So we wouldn't want to choose that one.
If it was positive one, would it be the same sign?
Yes. So we would say then tan inverse of -1 is equal to 7 pi over 4. Does that fit inside of our range? No. Oh. What do we have to do? Minus 2 pi. Why are we minusing? It's too big, right? 7 over 4 is 1.75. That's much bigger than a half. That's the top of our range, is pi over 2. So a half a pi, 0.5 pi. So to do that subtraction, we make a common denominator again. What will the common denominator be? 4. So 2 pi turns into 8 pi over 4. And when I subtract 7 pi from 8 pi, I get -1 pi. So our real answer is -pi over 4. What do you guys think? It's okay, right? Very visual, like you're looking at the unit circle, like you're not doing any algebra really by hand. You're using the unit circle. So far, so good? Okay, we're going to add one more layer on top of this now. So, slightly different problem. So here we've changed the setup a little bit, right? I've turned this now into a solving problem. And I've told you a location which I want the answer to fall within. Why do I need that? Otherwise, this has infinitely many solutions, right? Because sine goes up and down and up and down and up and down and up and down, and it keeps crossing or taking the y-coordinate of 1/2 over and over and over again, right? So this would have infinitely many solutions if I did not specify, I want the answer that falls here. You okay with this? So what we're going to do is we're going to look at two things to kind of get started, and then we're going to go to the unit circle. But before we go to the unit circle, we're going to do these two things first to reduce down our search space. Are you ready? So first thing I'm going to do, I notice that sine is positive because it's equal to positive 1/2. Everybody's okay there? If I go back to All Silly Turtles Crawl, what two quadrants is sine positive in? A for all and S for sine. So quadrants 1 and 2. Everybody's okay there? Now, now I'm going to use this and figure out what two quadrants are covered by those angles. So to do that, I'm going to start, I have 0. And are these angles positive or negative? Positive, so which way am I going to be counting? Clockwise or counterclockwise? Counterclockwise. So here is pi over 2. The next axis is at pi. And then we're at 3 pi over 2. That's the start. Ooh, okay. Everything afterwards is going to be covered then by this inequality, right? So I go to here. This is now 2 pi. And then I go to here, and that's now pi over 2. So I'm covering quadrants 4 and 1. Does everybody see how I did that? Where does my answer have to fall in? What location satisfies both the green and the yellow? Quadrant 1, right? That's where my answer is going to be. I've now narrowed it down to one specific quadrant to search in. Because we're looking at sine. What am I looking for in Q1? I'm looking for where y, because it's sine, is equal to 1/2. So if I drop in this, that's my answer. Or that's the angle I need, right? small problem. Is pi over 6 between 3 pi over 2 and 5 pi over 2? Or 5 pi over 2? No. Is it too big or too small? Too small. What should I do? Add 2 pi. Is everybody okay? To add pi over 6 and 2 pi, what do I need to have? Common denominator. What would the common denominator be? 6. So 2 pi becomes 12 pi over 6. And pi over 6 plus 12 pi over 6 gives me 13 pi over 6. And that will fall inside of my range. 13 pi over 6 is like 2 1/6, which is definitely between 1.5 and 2. Right? 3 over 2 is 1.5. 5 over 2 is 2.5. This is like 2.16. That's in there. Let's do that again, yes? Okay. Same kind of problem. Our next problem, cosine x is equal to -1/2, and we're looking for an answer between 3 pi and 4 pi. So I start. Cosine here is negative or positive? Negative. Because it's equal to -1/2. Everybody's good with that? From that, I'm going to go to my all silly turtles crawl. And where is cosine negative? So the letters are what's positive? 2 and 3, right? A, all of them are positive. C, cosine is positive. The other spots are where it must be negative. So far, so good? All right. Next thing we'll do is we'll go to 3 pi over 4. I'm sorry, 3 pi to 4 pi. So again, which way am I gonna? I'm gonna start at 0. Which way am I counting? Clockwise or counterclockwise? Counterclockwise, because they are positive. And remember, each quadrant is how much? It's a half, right? Half a pi. So pi over 2, pi. 3 pi over 2, 2 pi. 5 pi over 2, 3 pi. 7 pi over 2. Oh, by the way, here's 3 pi. Yay! And then 4 pi. So we're looking there. Yes, sure. Everybody okay now? Okay. So what quadrant should we be looking for our answer in? Quadrant 3. And what am I looking for in quadrant 3? Negative 1/2 in the x. Correct. Where do I see that at? 4 pi over 3. So this is like 1.3. Is that between 3 and 4? No. Is it too big or too small? Too small. So what should I do to it? Add 2 pi. Now to add 4 pi over 3 and 2 pi, what do I need? Common denominator. What would that common denominator be? 3. So 2 pi becomes 6 pi over 3. And 4 pi plus 6 pi is 10 pi over 3. And that's like 3.3. Is that between 3 and 4? Yes. So we're done. What would you do if it was still too small? Add another 2 pi and just keep going until you got what you're looking for.
I'm really confused on the fraction.
That's what I was trying to do. It's like writing above it what the decimal approximation would be by just typing the fraction part into my calculator and just kind of ignoring the pounds, right? Does that feel okay? What do you guys think? Do you think you ready to take a sheet, try some? Okay. Let me get you a sheet and we'll let you guys go. If you are missing your unit circle, I still have extras on top of the file cabinet. So if you're sitting down to work on this and go, gee, God, Willikers, I could really use a unit circle. There are extras on top of the file cabinet. Oh my goodness. Not your footprints. Computer over. This is the homework, yeah. We'll give you something physical because I feel like digitally it hasn't been going great for everybody. So I'm going to give you a specific sheet of paper to fill in that you can come and show me that you did it.
Do we turn this in?
Well, I might just check this one in person. Might be what we try doing because I haven't really been satisfied with the quality of work happening on the digital submissions for everybody. They've been kind of sparse and here's just a list of answers and I don't get to see much. I think that's been translating through onto the tests where we have trouble remembering the procedures. So we're just going to try doing it a little bit more old-fashioned. Now some of us are fine, right? But we'll try this and force more of us to make sure we're doing something, writing stuff down and having something to show. And okay, so you guys take the remaining 30 minutes here of class. I overshot how long that was going to take, but it felt like it was probably necessary. We did a lot of example there. At first, you guys were pretty unsure of things, so.
I was just gonna ask you.
We'll probably want to start going through things on it next class. I would try to have as much done as I can.
So are we not doing any more of the online assignments?
We'll still do some, but not all. So I'm going to start giving you guys physical handouts of things to do, in addition to some of the bookwork stuff also. But I think that
the first part of worksheet 4 is already started.
well, we'll eventually be doing worksheet 4. So if you've already started, that's okay. Yeah. I can tell that you know what's going on based on this. Yeah, so I'm not specific. Have work to show the test. So just have to questions. Sure. Gabby, what's up? Okay. Right, so tangent is on the unit circle, tangent is y over x, right? So you're looking for a place where y over x is equal to -1. So write down y over x equals -1. And then multiply both sides by x, so it's not a fraction. X don't want fractions. So you're looking for a place where x and y are the same number with opposite signs. Okay. So tangent is negative. You wrote down where it was positive. That's fine. That's okay. That's okay. I was unsure what you're asking me. I'm like, okay, well, let's plan this out. I see what you're talking about. But that's the issue, right? Now, if you're looking at quadrant 4, yeah, now it should be fine. Yeah, okay, no problem. Again, I highly recommend that you have your sheet out, get your unit circle out, make some progress on this, like cement this skill while it's freshest in your head. It'll be massively easier to pick this up later after you've like reinforced it on your own here. Know that we have other things going on, but like do some of this now while it's the freshest. It'll pay huge dividend later to go and pick this up to finish it. That you're like, yeah, I knew what I was doing here. I got this all solidified and I just have to finish this thing out. Or at least like, okay, I need to refresh myself on how to do it, but you have your own work to look at that hopefully makes more sense to you than maybe you have looking at my notes, not having to watch a video again, or do some now, get it, lock it in, you know?